Gold, a metal that has ignited human imagination for thousands of years. It is not the hardest, it is not the rarest, it doesn't possess properties that made it particularly useful in ancient times. Yet it became the symbol of wealth, power, and prestige. From ancient temples to royal crowns, to the vaults of modern central banks, gold has always represented something more than just a shiny metal dot in its glow. People saw divinity, immortality, and untouchability. For gold, oceans were crossed, continents conquered, empires built. Some lost their lives, others gained legendary fortunes. Gold was, and still is, the currency of dreams, giving a sense of security, status, and power. But behind this noble gleam lies fascinating science, brutal history, and the psychology of human desire. Why gold? What made it, out of more than 100 elements, the measure of value? And why even today, despite modern technology and digital currencies, can the world not let it go? Gold is a noble metal that has fascinated humans not only because of its shine, but also because of its extraordinary chemical and physical properties. Its very existence in nature is rare. It occurs in its native, nearly pure state, which sets it apart from most metals, which typically form chemical compounds. In the world of elements, gold is an absolute exception. It does not easily react with other substances. It does not corrode or rust, which allows it to retain its luster almost indefinitely. This resistance to external forces led ancient people to believe that gold was eternal, almost divine, immortal, compared to the fleeting materials of everyday life. The color of gold is equally unique. Most metals have a silvery or gray sheen, sometimes slightly shiny, sometimes matte. Gold, however, shines with a warm yellow hue, a rarity in the chemistry of metals. This distinct color comes from its electron structure, particularly the behavior of its valence electrons, which absorb and reflect light in a way that produces the characteristic yellow glow. Chemically, this is extraordinarily rare. Out of hundreds of elements, only a few display a similar natural color, and gold stands as the absolute leader in this regard. Physically, gold is soft and malleable. It can be drawn into thin wires, hammered into delicate sheets almost like paper, yet it does not break and maintains its structural integrity. This property has allowed humans for millennia to craft intricate jewelry, coronation regalia, and religious artifacts. Its electrical and thermal conductivity also makes it valuable in modern technology. From electronics to complex scientific instruments, even though most people still associate gold primarily with wealth and prestige, the rarity of gold in nature reinforces its value. While various precious metals are mined, gold is extremely limited geographically, appearing in flakes, nuggets, or ore deposits, where its concentration often does not exceed a few grams per ton of rock. Throughout human history, only a few 100,000 tons of gold have been extracted, a mere drop in the planetary ocean. This scarcity makes every gram of gold priceless, not only economically, but culturally, symbolically, and technologically. Gold is therefore an extraordinary element, resistant to time, retaining its shine. Rare, soft, and malleable, yet conductive. Its unique color, chemical resilience, and physical properties make it not just a symbol of wealth and power, but a natural marvel, a rare treasure among metals. It is a metal that has drawn humans for thousands of years and continues to captivate scientists, artists, and collectors around the world. Gold. The metal we hold in our hands that shines in vaults and adorns royal crowns did not originate on Earth. It is an element with a cosmic heritage, the birth of gold traces back to stellar cataclysms billions of years ago. Among the elements, it is exceptional. It does not form through ordinary chemical reactions or geological processes, but under extreme nuclear conditions that occur only in the hearts of the largest stars and in the dramatic finales of their lives. Let's start with the stars. Inside them, throughout their lifetimes, fusion reactions transform hydrogen into helium, and then helium into heavier elements like carbon, oxygen, and iron. But this process has its limits. In normal stars, gold does not form. It only appears during extraordinary, violent events, when massive stars explode as supernova or when neutron stars collide. During the colossal explosion of a supernova, as a star reaches the end of its life, neutrons and protons collide with unimaginable energy. In this chaotic process, known as the R process, elements heavier than iron are created, including silver, platinum, and gold. Even more spectacular, however, is the dance of elements during a neutron star collision. Extremely dense celestial bodies composed almost entirely of neutrons. When two neutron stars merge in a catastrophic explosion, a powerful neutron field is generated, in which heavy elements, including gold, are formed. Astrophysical calculations and observations in recent years confirm that most of the gold in the universe was produced in such collisions, where cosmic matter is ejected into interstellar space. But it doesn't end there. These cosmic fragments, dust, debris, and elements began to become part of the forming solar system. Gold created in explosions billions of years ago became trapped in asteroids, meteoroids, and interstellar gases that later formed Earth. As our planet took shape, most heavy elements, including gold, remained molten in Earth's blazing interior. During this time, the majority of gold sank to the planet's core, mixing with metallic iron and nickel. This is why the Earth's crust contains only small amounts of gold. Most of the heavy elements were locked deep in the core. Only later, during early Earth's history, about 4 billion years ago, did meteoritic bombardment enrich the planet's surface with gold that we can now mine from rivers and deposits. Every gram of gold on Earth is, in essence, a fragment of cosmic history, a testament to exploding stars, colliding neutron stars, and a journey spanning billions of years through space before finally reaching our planet. When we look at gold, we see more than a metal. We see the remnants of the universe's dramatic processes, traces of events that surpass human imagination. Every glint of gold in vaults, every coin or ornament, is a piece of the history of stars that long ago burned out, yet whose final explosions continue to leave their mark in our world. Gold is not just a symbol of wealth and power, it is a testament to cosmic alchemy, a universal story of the birth of elements in the fire of stars, and of how matter from the farthest reaches of the universe found its way into our hands. The gold we know and cherish is not evenly spread across the planet. It is rare, but where it does appear, it often forms spectacular formations. This is an element that, because of its cosmic past and chemical nature, ends up in specific geological structures rather than mixing evenly with other minerals. To understand its distribution, we have to look at the Earth as a dynamic organism, where gold migrates, concentrates, and becomes trapped in various environments over millions of years. Most often, gold occurs in the form of nuggets, tiny grains, or as so-called native gold in vein rocks. Quartz veins are one of the most characteristic places where gold finds shelter. In these veins, the metal appears in rock fissures as thin, gleaming bands or tiny crystals embedded in quartz. Often, these are small but rich concentrations that have attracted treasure seekers for centuries. Gold in river sediments looks a bit different. There, through the erosion of mountains and rocks, the element undergoes mechanical transport. Due to its weight and density, gold settles in riverbeds, forming what is called alluvial gold. Tiny grains, often hidden in sand and gravel, sometimes glinting in the sunlight like golden dust. This natural process of selection has made certain rivers true repositories of the precious metal. And alluvial gold has been a starting point for fortune hunters for centuries. Gold does not spread randomly on Earth. It forms so-called gold belts, geological zones where it appears in larger quantities, connected to tectonics and the geological history of continents. One of the most famous belts is the Archean Gold Belt, stretching from Canada through parts of Africa, Australia, and even Asia. These are areas where the Earth's crust was once extremely geologically active. Deep magmatic and hydrothermal processes allowed gold to be transported and concentrated within rocks. In these zones, both rich quartz veins and sedimentary gold deposits can form, later to be washed out by rivers and collected in natural geological traps. Certain regions of the world have become legendary because of gold. South Africa and its Witwatersrand Belt hold some of the oldest and richest deposits, shaping the continent's history for decades. In Australia, regions like Kalgoorlie and Victoria fueled the great gold rushes of the 19th century, leaving a mark on the country's history, economy, and culture. In North America, Canada and the United States have gold belts in the Rocky Mountains and in the Klondike region, which drew thousands of prospectors during the gold rush era. In Asia, Russia's Siberia hosts rich deposits, and some rivers are known for alluvial gold, which has been a source of local wealth for centuries. Gold also appears in more unusual forms. Sometimes in rocks, it can be found in microcrystalline form, embedded in other minerals, creating unique natural compositions. Occasionally, it occurs as so-called primary alluvial gold, grains trapped in clay or gravel, older than the modern riverbeds, almost like geological time capsules. These natural gold traps testify to millions of years of erosion, transport, and deposition, which delivered the metal into human hands only in the 20th century, even though it had been forming in the hearts of stars billions of years earlier. The oldest methods of gold extraction date back thousands of years and were remarkably simple, yet incredibly effective. Long before deep mines existed, long before humans learned to use machinery and chemistry, gold was sought where nature itself revealed it, in rivers, streams, and alluvial deposits. This is where the first prospectors found their initial treasures, and the methods they used were both an art of observation and patient labor. The most famous and oldest technique was gold panning. The entire philosophy of this method relied on the physical properties of the metal. Gold is heavy, dense, and resistant to erosion or destruction. Prospectors, standing in cold water, would scoop gravel and sand into a flat pan, often made of wood or clay, and slowly swirl it in the water. Lighter particles of sand and silt would wash away from the pan, while the heavier gold particles settled at the bottom. This process required not only patience but also experience. To know where in a river gold would accumulate, one had to observe the natural traps in the riverbed, bends, riffles, rock ledges that caught the heaviest particles. Alluvial gold in rivers appeared in various forms. Sometimes it was fine dust, sparkling in the sunlight like a golden mist, and other times larger grains and nuggets. The best places for panning were where the water's current slowed, allowing heavier particles to settle. Over time, prospectors learned to read rivers like maps, knowing that bends, deep pools near rocks, and areas of slower flow were natural warehouses of gold. In some cultures, gold panning became a ritual, almost a ceremony. The ancient Egyptians and Incas believed that gold in rivers was a gift from the gods, to be discovered through patience and knowledge passed down through generations. Manual labor, focus, and precision in moving the gravel were key. There were no shortcuts, no machines. Everything relied on observation, the feel of the water, and the ability to distinguish gold from other dark, shiny minerals like pyrite, known as fool's gold. Over time, other traditional techniques developed to aid panning, such as using sluices or wooden troughs, where water was directed along layers of gravel, allowing heavier particles, including gold, to settle into specially designed grooves. Prospectors had to demonstrate patience and perseverance. Gold was not always easy to find and often required weeks, even months, of systematic work to collect a significant amount of flakes. It's important to remember that traditional gold panning was not only a method of extraction but also an educational and observational process. Through it, humans learned to read nature, predict river behavior, understand geology, and identify natural gold deposits. From this simple, physical practice arose the foundation of all later knowledge about gold geology, about where to search for veins in rocks and where the largest deposits formed. Today, although machinery and chemistry dominate the gold industry, traditional panning still exists, both in historical gold rush regions and in hobbyist prospecting. Every tiny speck of gold found in river sand is not just a piece of metal but a fragment of a millennia-old history of human pursuit and collaboration with nature. Proof that patience and perseverance have always been the prospector's most essential tools. When we think of gold mines, the first images that come to mind are 19th century shacks in the American mountains, wooden tunnels in Africa, or narrow shafts in the mountains of Europe. In those days, mining gold from underground was an extremely hard and dangerous job. Miners had to push through rock, digging by hand with picks and hammers, and each additional layer of rock demanded enormous physical effort. The tunnels were narrow and low, with light reaching only from oil lamps, candles, or fire. Every day in the mine was a delicate balance on the edge of risk, from collapsing tunnels, toxic gases, to uncontrolled flooding. The oldest mining methods were based on simple principles. Miners sought gold in quartz veins, thin bands of rock where the metal was concentrated. The rock was drilled, broken, and searched manually, then crushed and panned to separate the gold from the stones. Extraction was painstaking, slow, and limited by human muscle power. In many regions, mines were shallow because only the surface layers could be accessed safely without the risk of collapse or the need for more advanced technology. Over time, the first machines to assist miners appeared. Water wheels, cranes, pumps to remove water, all designed to reach deeper layers. Yet the limit remained technology. Mines could not go too deep without risking disasters and without efficient ventilation systems. Miners had to rely on their endurance, experience, and ingenuity. Many old mines today remain abandoned corridors, full of legends and stories about the gold discoverers of the past. Today, the world of gold mining looks completely different. Modern mines are massive, automated complexes, reaching hundreds, even thousands of meters below the surface. The machines used in today's mining can break rock, transport the ore, and then send it to gold enrichment processes. Tunneling, ventilation systems, automatic drills, and controlled explosions allow access to areas where humans could never enter. Deep mines, like those in South Africa's Witwatersrand region, reach kilometers underground, almost like underground cities, with transport systems, elevators, and a full engineering infrastructure. Importantly, modern mines are not limited to quartz veins. Thanks to geology and technology, we can now access deposits dispersed in igneous rocks or formations that were once unreachable. Geological monitoring systems allow us to predict where the metal concentrates, and through enrichment techniques and chemical processes separating gold from rock, we can extract even very low-grade deposits that would have been completely uneconomical in the past. The difference between old and modern mining is not only about technology, it's also about scale and safety. In the past, miners risked their lives in cramped tunnels without rescue systems or ventilation. Today, strict safety standards apply in mines, including gas monitoring, emergency exits, protective equipment, and evacuation procedures. Extraction is more planned and controlled, and miners often work alongside robots and machines performing the heaviest physical labor. We must also not forget the environmental impact. Modern mines aim to minimize damage, using technologies to reduce erosion, control chemicals, and recover water. Gold mining is no longer just a physical struggle of humans against nature, as it was in the 19th century. It has become a complex process, combining geology, engineering, chemistry, and logistics on a global scale. Gold mining, though it has fascinated people for centuries and brought immense wealth, comes with serious ecological challenges. Gold does not occur in easily accessible forms. It is usually found in small amounts in rocks, river gravels, or deep veins. Extracting the metal requires enormous amounts of energy, significant landscape intervention, and the use of chemicals that can permanently alter the natural environment. Ever since the first gold rushes, when prospectors panned river sand, side effects appeared. Rivers were clouded, gravel was disturbed, and riverbeds disrupted. Over the years, the problem has become even more complex. Alongside the rise of industrial-scale mining, one of the greatest ecological challenges is soil erosion and degradation. Mines, both open pit and underground, disturb surface layers of the earth, destroy natural vegetation, and disrupt the natural water cycle. Altering the landscape to access deposits sometimes means completely transforming ecosystems. Hills are cut down, forests cleared, and natural water sources diverted or blocked. As a result, local fauna and flora are displaced or even wiped out within mining zones. Chemical pollution is another serious threat. Traditional industrial techniques, such as using cyanide or mercury in gold extraction and enrichment, can contaminate surface and groundwater. Mercury, historically used in gold amalgamation, enters aquatic ecosystems and accumulates in fish, becoming a source of poisoning for both humans and animals. Cyanide, used in modern chemical processes, is extremely toxic and requires precise management. Any leaks can have catastrophic consequences for rivers, lakes, and surrounding agricultural lands. Another issue is the massive volume of rock waste and tailings. Gold extraction, especially in open-pit mines, generates tons of mined rock, often stored in heaps. These heaps can cause erosion, landslides, and leaching of heavy metals into soil and groundwater. Long-term exposure of ecosystems to such waste can lead to lasting contamination and disruption of the biological balance in the region. Exploiting deposits also has long-term effects on the geological structure itself. Mining deep quartz veins and igneous rocks, which took millions of years to form, leads to permanent changes in the subsoil structure. Overly intensive extraction can cause land subsidence, rock fractures, and changes in groundwater flow, which in turn affect the stability of surface ecosystems. However, today's gold industry strives to respond to these challenges. Modern mines implement water purification systems, chemical monitoring, and waste recycling. Technologies are emerging that reduce the use of mercury and cyanide, as well as mechanical gold enrichment methods that avoid toxic substances altogether. Contemporary geology and environmental engineering aim to minimize damage and restore areas after mining operations through reclamation of tailings, replanting vegetation, and restoring natural river courses. Gold mining, therefore, is a delicate balance between economy, history, and nature. It is a metal that has fascinated humanity for millennia, but it also demands immense environmental responsibility. Every ton extracted from a mine is not only material value but also a footprint left in the ecosystem. The future of the gold industry depends on our ability to reconcile the demand for this precious resource with the necessity of protecting nature and minimizing the impact of mining activities on our planet. Gold is not only a symbol of wealth and beauty, but also an extraordinary metal with unique chemical and physical properties that have fascinated scientists, artisans, and artists for centuries. At first glance, it stands out with its characteristic warm, yellow glow, a rarity in the world of metals. Most metals are silvery, gray, or steel-colored. Gold is truly exceptional, and its visual charm goes hand in hand with equally remarkable physical properties. One of gold's most well-known traits is its softness and malleability. It is a metal that can be easily bent, drawn into wires, or hammered into thin sheets. Historians and craftsmen often note that a single gram of gold can be stretched into a wire up to 2 kilometers long. When it comes to rolling, just 1 gram can produce a sheet roughly 1 square meter in size. In practice, this means gold is so soft that in the hands of a skilled artisan, it becomes almost a magical medium for creativity. That's why for millennia, gold has been the perfect material for art and jewelry, allowing delicate filigree, thin leaves, intricately decorated crowns, sculptures, and even temple ornaments to be crafted with precision. Yet, gold's softness is also a practical challenge. Pure gold, marked as 24 karat, is too soft for everyday use in jewelry or mechanical components. That's why jewelers often alloy it with metals like silver, copper, palladium, or nickel, creating blends that retain gold's shine and color while gaining additional hardness. These alloys allow the creation of rings, bracelets, and watches that are durable yet retain the beauty of pure gold. Gold is also an excellent conductor of heat and electricity. While copper and silver conduct slightly better, gold has one irreplaceable advantage: it does not corrode or oxidize. This makes it indispensable in high-end electronics and microchips, connectors, circuits in phones, computers, satellites, and precise laboratory instruments. Even in extreme conditions, in humidity or in the presence of chemicals, gold connections maintain full functionality, making it ideal for critical technological applications. Another fascinating aspect of gold is its chemical inertness. It is a noble metal, meaning it does not react with most acids or oxygen at room temperature. It does not rust, corrode, or darken over time. Unlike iron, copper, or silver, gold retains its properties for millennia, which explains why ancient coins, jewelry, and ornaments are still almost perfectly preserved. This chemical stability is what made gold a symbol of enduring value and permanence. Across cultures worldwide, gold is also biologically neutral. This means it rarely causes allergic reactions when in contact with human skin or tissues. For many people, this allows them to wear gold jewelry without concern for irritation. In medicine, gold is used in implants, dentistry, and treatments for certain conditions, such as rheumatoid arthritis in the form of chemical compounds. It does not react with enzymes and is non-toxic in standard applications, making it a unique metal with an exceptional combination of durability and biological safety. Modern science has also discovered gold's potential in nanotechnology and chemistry, Gold nanoparticles exhibit catalytic and optical properties that are not present in bulk metal. Nanogold has become a key material in medicine, diagnostics, and photonics. Gold nanoparticles are used to deliver drugs in the body, detect diseases, and even create new types of sensors and optical displays. This shows that gold is not just a beautiful metal, but also a material with extraordinary scientific and technological potential. Finally, gold's versatility is remarkable. It can be combined with other materials almost without limit. It can be embedded in glass or ceramics, form reflective coatings, or used in photography and jewelry as almost transparent leaves and flakes that retain their golden shine. Its physical and chemical properties allow the creation of artworks that amaze with their detail, durability, and brilliance, something no other metal can achieve. In summary, gold is almost a magical metal, soft, malleable, conductive of electricity and heat, chemically inert, and biologically neutral. It can be shaped into the finest artistic details while also serving the most advanced technological purposes. Its unique color, rarity, durability, and biological neutrality make it unmatched in the periodic table. This is why gold has captivated and inspired both artists and scientists for millennia, standing as a symbol of beauty, excellence, and technological perfection. Gold is a metal that has accompanied humanity for thousands of years. The oldest discoveries date back over 5,000 years. Archaeologists have uncovered gold ornaments in tombs in ancient Egypt, as well as in Mesopotamia and Anatolia. Even then, gold was not just a beautiful metal. It held symbolic and practical value. In Egypt, pharaohs considered it the blood of the gods, and golden ornaments and jewelry were signs of power, prestige, and immortality. Tombs of kings were filled with golden masks, amulets, and cups, not because gold was useful in everyday life, but because its shine, durability, and rarity gave it an extraordinary significance. Over time, gold began to serve an even more practical purpose. In ancient Lydia, during the 7th century BCE, the first gold coins were minted, facilitating trade. The metal became a universal medium of exchange, accepted and valued across cultures. In the Middle Ages, gold coins minted by kings and emperors shaped the economies of entire continents, and their abundance determined the power of nations. Gold set the standard for the value of money, and control over its sources was one of the most crucial elements of politics and warfare. Even in modern times, gold's role in the economy has not disappeared entirely. Although we now use paper money and digital currencies, gold remains the foundation of many nations' central reserves. It serves as a kind of safety net within the financial system in times of crisis. Investors flock to gold because its value is enduring and resistant to inflation. Gold continues to influence global markets, currency exchange rates, monetary policy, and the decisions of central banks. Owning gold provides confidence in the face of global economic volatility, and its price often acts as a barometer of investor trust. Gold also reminds us that economic value and cultural significance are deeply intertwined. It is a symbol of wealth, power, and prestige, while simultaneously functioning as a financial instrument. Its value is shaped not only by mining and supply, but also by geopolitics, technological changes, and industrial demand. Today, investment banks, funds, and nations treat gold as a safe haven during uncertain times. Much like people in ancient Egypt safeguarded it in the tombs of their rulers. Gold shows us that a metal can be more than just a resource. It is a bridge between history and the present, linking art, religion, and prestige with finance and the global economy. Its rarity, durability, and universal acceptance have shaped the fate of nations, peoples, and entire continents for millennia, and it is likely to continue doing so for many centuries to come. Gold captivates people not only with its value, its shine, and its history, but also with its extraordinary properties and its presence in places most of us never even think about. Let's begin with the human body. Remarkably, gold exists within us as well. On average, about 0.2 milligrams of this metal circulate in our blood and tissues, playing a role in certain enzymatic processes, although its exact biological functions are still being studied. It's not much, but it shows how common yet subtle gold can be in nature. Gold is also present in seawater, though in very low concentrations. It is estimated that all the oceans of the world contain roughly 20 million tons of gold. Yet it is so dispersed that extracting it directly from seawater is currently not economically viable. Still, the presence of gold in the oceans is a fascinating reminder that this metal circulates in Earth's geochemical cycle, transported by rivers, mountain erosion, and mineral deposits before finally reaching the seas. One of gold's most astonishing qualities is its softness and malleability. Pure gold, 24 karat, is so soft it feels almost like clay to the touch. It can be kneaded, formed into thin sheets, and bent without risk of breaking. It is precisely this remarkable malleability that allowed ancient artisans to create intricately decorated masks, jewelry, and temple ornaments that continue to impress with their precision and beauty. Gold can also be drawn into wires of incredible length. A single gram of gold can be stretched into a wire up to 2 kilometers long. This makes gold an exceptional material in both jewelry and electronics. It can form extremely fine conductors that carry electricity while maintaining all of its physical properties. Rarity is another aspect of gold that has fascinated humanity for millennia. Although gold has been mined for thousands of years, and mines around the world still produce hundreds of tons annually, if all the gold ever mined throughout history were gathered together, it would fit into just a few large buildings, roughly the size of a small stadium. This demonstrates how limited and precious this metal truly is, explaining its status as the king of precious metals. Gold has also found its way into the culinary world. Edible gold, in the form of thin flakes or powder, is used in luxury desserts, high-end drinks, and as decoration on cakes. Biologically inert, it passes through the digestive system without reacting, and has no taste or smell, yet it adds a sense of prestige and elegance. From ancient Egypt to modern fine dining, golden cuisine symbolizes wealth, sophistication, and uniqueness. We must not forget gold's role in science and technology. Its ability to conduct heat and electricity, its resistance to corrosion, and its durability make it indispensable in electronics, medicine, and even space technology. Gold coatings protect instruments and satellites, while thin foils are used in precision sensors, lasers, and medical devices. Every atom of gold holds both beauty and utility, combining artistic elegance with scientific purpose. Furthermore, gold can be shaped in nearly limitless ways. It can be fused with glass, applied as reflective coatings, layered on ceramics, or leather, or combined with other metals and minerals in extraordinary compositions. Its durability and brilliance ensure that creations made of gold last for centuries, bearing witness both to the skill of the artist and the remarkable properties of the metal itself. In conclusion, gold is a metal that never ceases to amaze. It exists within our bodies, in the waters of the oceans, yet it remains rare and treasured above all other metals. Its softness, malleability, ability to be drawn into wire, conductivity, chemical resistance, and biological neutrality make it both an artistic and scientific material. And the fact that it can even be eaten adds an almost magical quality. Gold is not merely a metal. It is a symbol of rarity, durability, and extraordinary beauty in every aspect of human life. Gold has never been merely a metal. It is a symbol that has permeated all spheres of human culture, from religion and art to philosophy and mythology. The ancient Egyptians considered gold the blood of the gods, a bridge to the divine realm. Pharaohs were surrounded by gold not only in life but also in death, in their tombs, in masks, jewelry, and sarcophagi. The radiance of gold symbolized immortality, durability, and divine protection, making the metal synonymous with eternity. During the Middle Ages, gold gained philosophical and alchemical significance. For centuries, alchemists sought the legendary philosopher's stone, believed to transform ordinary metals into gold. This pursuit was not driven purely by greed. Gold symbolized purity, perfection, and spiritual enlightenment. Every alchemical process aimed at a golden transformation was also a metaphor for human transformation, the purification of the soul and the attainment of harmony. In this way, gold in culture became more than a mere element. It became a symbol of perfection and immortality. In art, gold has played and continues to play a central role. In Christian and Buddhist iconography, golden backgrounds and icons in paintings represented divine presence and heavenly light. In illuminated medieval manuscripts, gold highlighted Key words and images, drawing the eye and imparting a nearly mystical aura to the work. During the Renaissance, golden details adorned altars, statues, and architectural ornamentation. Merging aesthetic appeal with spiritual symbolism, gold's cultural significance extends beyond religious symbolism. It became a symbol of power, prestige, and wealth. Crowns, scepters, royal insignia, and medallions were crafted from gold to emphasize the ruler's status and authority. Even in literature and poetry, gold appears as a metaphor for perfection, beauty, and eternity, something mankind desires, yet something that remains unchanged despite the passage of time. In contemporary art, gold retains its significance. Artists use thin gold leaf, wires, or powder to create works that blend tradition with modernity. Installations, sculptures, paintings, and even haute couture jewelry demonstrate that gold continues to captivate with its unique aesthetic. Its brilliance, rarity, and durability make each gold creation a symbol not only of material wealth, but also of intellectual, spiritual, or emotional value. It is important to remember that for centuries, gold has combined material and symbolic worth. It is a metal that has survived millennia, witnessing the birth of civilizations, great discoveries, and cultural transformations. In every era, gold has inspired creation, from ancient golden masks to medieval manuscripts, Renaissance masterpieces, and contemporary art and design. As a symbol of eternity, perfection, and divinity, gold remains one of the most powerful and universal symbols in human history, uniting aesthetics, spirituality, and prestige in a single, unchanging radiance.